2025 A-Level Combined Mathematics Paper 2 Part A question number 6. This question has to do with vectors. The question says, let alpha, beta and gamma be elements of the set of real numbers minus the set of 0, which basically means that alpha, beta and gamma can be any real constants except for 0. Now given this, it says, in the usual notation, let A vector be alpha times I vector plus beta times j vector, and B vector be gamma times I vector minus beta times j vector. Be two vectors satisfying modulus of A vector squared plus modulus of B vector squared equals 1. Given this information, we are asked to show that alpha squared plus 2 beta squared plus gamma squared is equal to 1. Now after this, they say it is given that the vectors A vector and B vector are perpendicular to each other. Given this information, we are supposed to show that beta squared is equal to alpha gamma and then find the value of gamma if alpha is given as 1/3. Now to start off this question, what we need to do is to use this information here and the fact that A vector modulus squared plus B vector modulus squared is equals 1 in order to find this equation. Now in the usual notation, I and j vectors are two unit vectors that are perpendicular to each other. So here we have alpha times one unit vector plus beta times a perpendicular unit vector, and here we have gamma times unit vector minus beta times another unit vector, which is perpendicular to the first one, of course. So now given this, since we know that I and j are perpendicular unit vectors, if we consider the modulus of A vector squared, it's going to be the coefficient of the first unit vector I squared, which is going to be alpha squared, plus the coefficient of the second unit vector, which is j squared, which in this case is beta squared. Now then, considering B vector's modulus squared, we can see once again, since we have two unit vectors perpendicular to each other, the modulus here is going to be the first unit vector's coefficient, which is gamma squared, plus the second unit vector's coefficient, which is negative beta squared. Now here, since we have squared, negative beta squared is the same thing as beta squared, so simplifying we get gamma squared plus beta squared. Now from this, we know what the modulus of A vector squared is and we know what the modulus of B vector squared is. Since we know that modulus of A vector squared plus modulus of B vector squared is equal to 1, adding the two together we can see alpha squared plus beta squared, which is the first set, plus gamma squared plus beta squared, which is the second unit vector, second vector square, is going to be equal to 1. And we can see, simplifying this down, alpha squared plus beta squared, which is going to be plus 2 beta squared plus gamma squared is equal to 1. And hence, we have shown what we wanted to show. Now I'm going to call this equation 1, underline it and move to the next part of the question. So at this point, we've shown that alpha squared plus 2 beta squared plus gamma squared is equal to 1. Now for the next part of our question, we have that the vectors A vector and B vector are perpendicular to each other. So if two vectors A vector and B vector are perpendicular to each other, we know that the dot product is going to be equal to 0. So we can say if A vector comma B vector are perpendicular, this implies that A vector dot B vector is equal to 0. Now we can use this to our advantage, because if we find A dot B, we can equate it to 0, which will give us another equation in terms of alpha, beta and gamma. Now if we consider what we have, again we have two unit vectors perpendicular to each other and coefficients of them, and in this B also we have two unit vectors with coefficients in front of them, and these two unit vectors are perpendicular to each other. So we know if we have two vectors of this form, when we take the dot product, it is simply going to be the two coefficients of the I vectors multiplied together plus the two coefficients of the j vectors multiplied together. So if we take that, we can see that this dot product being equal to 0 means that the product of the two I coefficients multiplied together, which is going to be alpha times gamma, plus the two j coefficients multiplied together, which is going to be beta and minus beta. So we have plus beta times minus beta is going to be equal to 0. Now we can see, if we rearrange this, we are going to get minus beta squared here and alpha gamma here. Taking minus beta squared to the other side, we can see that this implies that beta squared is equal to alpha gamma, which I'm going to call equation number 2. And equation number 2 is one of the equations that we need to find. We need to show that beta squared is equal to alpha gamma. So there, we've done that part of the question as well. Now for the final part of the question, we are asked to find the value of gamma if alpha is equal to 1/3. Now if alpha is equal to 1/3, we can say if alpha equal to 1/3, from equation 2 we can directly see that beta squared is going to be equal to gamma divided by 3, which we can rearrange to get that gamma is equal to 3 beta squared. Now I'm going to call this equation number 3, and additionally we can also see, since beta is an element of the real numbers, beta squared is going to be a positive number, multiplied by 3 is still going to be a positive number, so therefore this is going to be greater than 0. So gamma is going to be greater than 0, and 3 beta squared is also going to be greater than 0. I'm going to call this equation number 3, which we will be using later. So now, with this, if we consider our first equation from equation number 1, if we substitute into equation number 1 the fact that alpha is equal to 1/3, and we also substitute 3, which I'll actually write as 1, 3, from 1, 3 we can see alpha squared is going to be 1/3 squared, which is going to be 1/3 squared, plus 2 times beta squared, which we know beta squared is going to be equal to gamma divided by 3. So we have gamma divided by 3. And finally we have gamma squared, which I'm going to leave as gamma squared. So plus gamma squared, and that is all equal to 1 from this equation. So equals 1. Now we can see what we have is a quadratic in terms of gamma. If I simplify this down, we can see we have 1/9 plus, and here we have 2 gamma over 3, and gamma squared equals 1. If we multiply everything by 9 and take everything to one side, we can see this minus 9 is going to give us minus 8/9 here. Multiplying everything by 9, we can see we are going to get 9 gamma squared. This is going to become 6 gamma, so plus 6 gamma, and then minus 8 equals 0. So we get this equation here. Now we can either use the quadratic formula to solve it, or we can factorize. Now in this case, I know the factorization, and I know that the factorization is going to give me 3 gamma minus 2 times 3 gamma plus 4 equals 0. Now you can do it either by factorization. If you see the factorization, you know, here we have a coefficient of 3 gamma. Here also we should have 3 gamma, since it multiplied together gives us 9 gamma squared, and then we can find these integers. Or if you can't do that, you can go to the quadratic formula and solve it that way as well. So anyway, when we get these two, we can see we have two roots. One where 3 gamma minus 2 is equal to 0, and one where 3 gamma plus 4 is equal to 0. If we simplify them, we can see we have gamma equal to 2/3 here, or gamma equal to negative 4/3 here. So negative 4/3 here. So we have two roots. Now the question is, which of these two roots is the correct root? So we can see up here, gamma is equal to 3 beta squared, which is greater than 0, which means that gamma must be a positive number. But this root gives us that gamma is equal to a negative number. So we can say that this root cannot be the case, since gamma must be equal to a positive number based on 3. So we can say from 3, we can see that gamma must be equal to 2/3. And we can say as gamma is greater than 0. So therefore our answer here is gamma equals 2/3, and that's going to be the final answer for this question. Finally, if we consider the marks order for this question, at the start, when you find the modulus of a squared and the modulus of b squared like this, you get 5 marks. When you then substitute those two values in order to get equation number 1 here, this equation alpha squared plus 2 beta squared plus gamma squared equals 1, you get another 5 marks. Now after this, when you apply the principle that when the two vectors are perpendicular, their dot product is going to be equal to 0, and you write down this equation right here, you get 5 marks. After that, for the particular case of alpha equals 1/3, when you substitute and get this quadratic right here, you get 5 marks for that. And finally, when you simplify down, you get two solutions, and you say that since gamma greater than 0, this solution is invalid, meaning that gamma is equal to 2/3, and write down gamma equals 2/3 as your final answer. You get 5 marks for that. So that is going to be all for this question. If you have any feedback, post in the comments down below. I hope you enjoyed. Thank you for watching, and goodbye.